Hey, my name's Marwan Yakut. I'm a computer science student at the University of London. Welcome to the Python Bootcamp for beginners. This bootcamp is a hands-on practical course designed specifically for those who have little or no prior coding experience. Whether you're looking to start a new career in Python or just simply explore coding and try to understand how Python works, this bootcamp is for you, especially if you're later on pursuing your career in artificial intelligence. I can confidently say that this bootcamp is one of the most beginner-friendly programming bootcamps in the world. So, the bootcamp will be introducing three primary curriculums: Python Fundamentals, Python Core, and Python Master. Python Fundamentals will provide you with an introduction to Python, the basic syntax and data types, operations and expressions, and control flow. Python Core will introduce you more about functions, data structures, basic file handling, error handling, and classes, which is object-oriented programming. And finally, Python Master with the libraries API, Flask, and File I/O. And there might be more to be added in the future. So now let's understand what is Python. Python is a language that was made by another language called C to make programming easier. It has variables, functions, loops, regular expressions, conditionals, libraries, and exceptions, which are all terms that you will become familiar with during this bootcamp. For you to actually write code in Python or to actually code in Python, you need something called an IDE. An IDE can be practically anything you can write code in. This can even be Microsoft Office Word, but of course, it's not recommended to actually write code in Microsoft Office. Instead, you can use one of the most popular programming IDEs out there, like PyCharm, VS Code, Jupyter Notebooks, Xcode, and more. This course in specific, we will get to use VS Code as our primary IDE. And now, let's get to the part where we learn how to download and install VS Code so we can start programming together. Let's begin. Before I go, I want to make a few words for those who are looking to actually change their lives. I want you to know that you don't need a degree to actually become successful, and you don't need to know a lot about programming so you can actually start programming. For you to learn the basics of programming is not a difficult task. It just requires you to be a little committed so you can get to understand how it works. And once you get to learn the basics and the fundamentals, it will become very easy for you to keep up and maintain your programming skills. Programming is not like in the movies. Do not expect yourself to be coding fast on a computer, and do not expect that coding fast on a computer makes you a good programmer. The most professional programmers out there take days, weeks, months, and even years to make the most perfect programs for us to use. So do not be discouraged and do not feel demotivated from the beginning. Finally, thank you so much for listening and being a part of this course. So now let's download VS Code. All we need to do is go into Google and then type in the search bar VS Code. And then we would Google search and then hit the first link, or just go straight to download from here. This page will pop up for you, and then you can choose your platform. If you're using Linux, you can download this. If you're using Mac, if you're using Windows, you can download this. So we are using Windows, so we will download this, and then we will head on with the installation process, and then we will go on to the next part of our bootcamp. Welcome back, everyone. By now, you've installed successfully VS Code on your computer. Now let's go real quick over the UI, or the user interface of the program itself. You can hover here on the top left corner and you would find the Explorer tab. If you click on it, it will allow you to open folder, which will allow you to specifically open a folder that is on your computer, or to clone a repository, and that's connected to something called GitHub, which can be explained in other tutorials or bootcamps. GitHub, in simple words, is more of a space that allows you to save your code so it's accessible by everyone around your sphere, or basically become open source to every other coder outside in the world. And then the second tab would have a search tab. This allows you to search some words or basically functions that will be written within your code. And then you can actually replace them if you provide another additional text that will allow you to replace the entire thing in the entirety of the code, not just in one instance. The source control would allow you to control the repository through GitHub. The run and debug section would allow you to run and debug your code. We will go briefly over debugging, and we would know how exactly to work and debug our code. The extensions section here will allow you to add and install some extensions to your VS Code. For example, the first extension that we will install today will be Python. If you search for Python, you will find Python by Microsoft. If you click on it, you click install. I have already installed it, so it's not giving me the option here, but on yours, it will give you the option to install. And then you can check auto update, so it updates with the latest new updates. There's also another extension that will allow you to make your code neater, which is called prettier. This extension provides you with the ability to make your code look better every time you click save. We will see how it works during our coding. And now there's Remote Explorer. And finally, we have the Remote Explorer. This will allow you to remotely control some of the repositories that you have or access them remotely. This is used for multi-collaborational work by teams that work from different places so that they can connect together and work on the same code. And now let's jump into our first code. We go back to our welcome page and we click on New File. We go up there and we make a new file, My First Program. And then we add the extension .py. Other languages may have different extensions, but for Python, the ending extension is .py. There's also different extensions for Python, which we will learn about later on. And now we hit enter. It will open up the file for you. You can choose where you save it. In my case, I've saved it in a desktop file called VS Code, and I'll hit create file. And now this is your IDE or coding environment. As you can see, the cursor here is at the top left corner. Let me zoom into you so you can see exactly how our code is. You can double click the Explorer section so it provides you with a full screen. You can also use the split screen on the top right to split your code. And this is very functional when it comes to multiple files, which we will later on become handy with. This will be exceptionally helpful when you have multiple files and you need to edit or look at something while you're coding. We don't need that now. So, we can check here that our go-to line is line 1, column 1, as our cursor here indicating. Spaces is for, or the indentations. This is basically every time you click tab, you would have 4 indentations. 1, 2, 3, 4, which is 1, 2, 3, 4 spaces. UTF-8 is type of encoding on which the computer will interpret your code. CRLF is basically a short for carriage return plus line feed. Usually this is the type of line sequence that is present within Windows. If you are running on Mac, you will find that this is an LF only, which is okay. Here the auto import completions is set to false. You could get to know about that later on. And next is Python. It's detecting that the language that we're going to use right now is Python because we've added the extension .py. If you click on it, you'll find plenty of languages such as C, Go, F, HTML, and all that other languages that can be used in VS Code. And here is the version of VS Code that we're using, which is 3.12.3. And now we can start right away with our first program. Let us start our first program using something nice. We can delete the indentations we made from earlier and now write down print and then open bracket and then 2 commas and then say hello world. Now if we go on the top right corner and click on run, it's going to open for us terminal, which will print out hello world. Terminal is also a very good tool that we will use during our execution of code. Terminal will help you know if your code is running into errors and help you create something that we will get to know on called environments, which are environments for your code. And now we can head on to the next part. After you've created your first program using the print function, we need to know what is print. Print is an already embedded function within the system. We would know what a function is later on the course, but we need to know how this function in specific works, because print is one of the most famous functions that you will commonly and consistently use on your code. So now we would need to know why did we use single commas. For example, we can add double commas instead. Now if I click run code, you will find that now I have been able to run the code including the commas on the top. And the same goes for the other way around. For example, if I wanted to include the double quotes instead of the single quotes, I can do this and then concatenate them in a single quote, so then it can show us the double quotes instead. And if we hit run again, now we have the double quotes instead. By convenience, we tend to use the single quotes, so we can add the double quotes whenever. It's usually self-reference. There is no standard in using which. Now let's jump into data types. There are specifically about 4 types of data types. The first is called an integer. Now let's delete this and clear here and hitting enter. Commands like clear will become handy to you as you get along in coding. You can learn more about the command prompt or the terminal commands using the CMD command list. There are a lot of commands which I will provide a link to within the section below this video. Now let's jump into the variable types. There are multiple variable types. For example, let's start with the most basic variable type. First, let's start with knowing what is a variable. The variable can be anything, starting from X, name, age, X, Y. These are all called variables. You can name anything a variable, literally anything. So, what makes a variable different from another variable? That's easy. For example, I can name a variable variable. So the variable here, by convenience, can be anything. In this case, it can be of type integer. And by the way, it's not convenient to use the name variable in your code. Sometimes you can use something that can indicate what the variable is standing for. In this case, we can change that to X. So now we have X equals 5. This is a variable of type integer. And you can see that it has here literal 5, which means indicating the type integer. We can also notice that there's an equal. The equal here is not an equal operator. It's an assignment operator. The equal operator would be the double equal, also referred to as the comparison operator. We will use some examples later on during the bootcamp of how can we use the comparison or equality operator. For you to understand how equality or comparison operator works, you need to imagine that each letter in the alphabet has its own value in something called ASCII code. Whenever we use the equality operator or comparison, we're basically comparing the ASCII code value of each letter in the alphabet. And each number, as well and simple, has its own value in ASCII code. If you want to know more about each value for each alphabetic letter in the alphabet, I would put a link in the description of the video so you can know more about it. So now let's jump into coding. Sometimes we can forget about what this means. We can forget about if x is actually an integer. So we can do something called a comment. A comment is basically conducted by adding a hash. For example, if I added anything after the hash, it will not be included in our code. And you can see that anything I put after the hash is in green color, which indicates that it is a comment. So now we can use this comment to help us go out through our code. Because if we have thousands of lines, we can easily forget what each code refers to what. In this case, we will add that x equals 5 is this is my integer. And now we can go for the second data type. Y equals 3.14, or pi in this case. 3.14 is not an integer, it's of type float. Now we can add that this is my float. The difference between a float and an integer is the decimal points. In an integer, you cannot include decimal points, but in a float, you can. By the way, as programmers, we tend not to use some subjective words in our comments. We tend to become more objective and directly to the point. For example, instead of this is my integer, we can change it to an integer. And here, a float. And we can have that there are variables. We can do the same here. This is more convenient and more professional. And now for the third data type, a string. I think you are already familiar what the string is. If we add it here, name, and assign it to my name, you can see that it's already yellowed out. And we have already did this before using the print function. This is called a string. You can add even numbers within a string, but they will not be counted as numbers, they'll be seen as a string. An integer can be used as an integer, can be added upon or subtracted from or multiplied with. However, a string cannot be. An integer can be transferred into a string, but a string cannot be transferred into an integer. This case is only unless the string has only numbers. So now we can jump into the fourth type of data types, which is a Boolean. We use Booleans to indicate if something is true or false. In this case, we can use something as a statement or asking a question. Is student? And we can have after it true. And notice that the true is capitalized first letter and then the rest is lowercase. So now this is called a Boolean value. And notice how I placed the underscore here. The underscore is basically a type of programming style. There are multiple programming styles. There are plenty of them. For example, there is camel case, snake case, Pascal case, kebab case, and uppercase with underscores, or even scream case. And there's even lowercase. So Let's see an example of each. For example, you can see in the camel case, we basically capitalize each first letter of each word. Snake case can be something like snake case, which is basically underscores. We can have this here so we can see exactly what a variable would look like in a snake case. Pascal case can be something like this. It takes some time and getting used to get familiar with the different types of styles that are used in coding. By convenience, the most famous ones are the camel case and snake case. The Pascal case is also used, but not more common than those two. So stick with those by now. The kebab case is basically not used in Python, so it goes something like this. You can see that Python does not accept kebab case. However, other languages might do so. There's also lowercase or scream case. Scream case would be something like this. And now you're familiar with the styling, we can go back to our code. isStudent is true. So now this is a variable. Now let's include the comment for each data type. String variable, a Boolean variable. So now we have all 4 data types. Now let's give an example of using those data types. For example, let's clear the first 2 and add age. I would say 25. Now let's make another variable and call it age. And let's equate it to 25. And now let's make another variable called fees. And let's have it with 100.25. So now we have all data types once more. Now let's comment it back. This is an integer. This is a float. And this is a boolean. Now let's use those variables and data types in our code. Let's use the print function once more. And we can say something like single quotes, my let's make some space here for our code. My name is, and space, and then we can add name. And then I am plus age, and then we can add another plus. We can say years old. Let's make a space here, and then a dot. Make here dot 2. This years old plus I am paying plus fees, and then we can add another plus dollars. So now it should print something that says my name is name, which goes to ma1 and just grabs ma1 and puts it back into the string, and now plus I am age, which is 25, plus years old, and then plus I am paying fees, which is 100.25, and then the is student, we will make another print, and then we can just simply say is underscore student. So now, by convenience, I should be able to get a string that says, hi, my name is Marwan, I'm 30 years old, and I'm paying $100.25. So, let's run the code. And oops, there is an error. The error is saying that we have an issue on line 6, and the error says that we can only concatenate string, not integer, to string. What does that mean? What he means is that we cannot convert the integer into string right away. We have to first use a function called string or int. For example, we can do so by doing the following. Here, for example, name is already a string, so it doesn't need to be converted. But an integer is not a string, so it does need to be converted. Now let's convert the age into a string by just simply adding the function string before it. str, and then we put 2 brackets. And now we do the same for the fees because it's a float. So we can just put an str function and it would convert the float into a string. And now if we run again, we will not run into the same issue. My name is Marwan, I'm 25 years old, I'm paying $100.25. So this is a way to print out our data types. There's also another way, which we will learn about right now. But now we can also see that the is student is also printed, which says true. He is a student. So now we can have another way to be able to put integers into strings without having to use the str or string function. For example, we would use the following, using print, and then the same way, but we would use something called the f string. We would just simply add an f before the double single quotes. So now we can have the same sentence, and you can say my name is, and then curly bracket, and then add name, and then dot I am curly bracket age years old, dot I am paying curly bracket fees. And now we can have dollars. And this is the same as this, but this is called an f string. An f string basically just says that, hey, convert anything we have into those curly brackets into the string automatically without the need of using the string function. So this makes it even easier for you. Now if we clear and then we run the code once more, you can say that they're both identical sentences. My name is Marwan, I'm 25 years old, I'm paying $100.25, and they're both identical. So let's clear this. There's also a third way of converting integers into strings, which is the following. We can have the print function, and we can do something that is called the percentage formatting, which adds basically my name is percentage s, which stands for string. I am percentage d, which stands for integer years old. I am paying percentage .2f. We would know what a .2f means right now, but this stands for float. Dollars. I know this might feel overwhelming, but bear with me. And then dot. And then after these single quotes, we can just simply add a percentage, then open bracket, name, age, and fees in those specific order. The name came first, which is the S, and D, age, and fees, float. So now we can print out this, and it would print us the same identical. We can see here I had, yeah, and now we can just clear it out and run the code once more, and you can see there are 3 identical sentences. But now I want you to know what's the difference if we added, why there's 2f. If we had here 1f, the decimal point after the 100 would only print out the 2. I added 2f so I can include the 0.25 in total. I did those 3 ways to show you that there are multiple ways to present the same statement using different ways of coding. These are 3 identical sentences, and now let's see what's the output if we used 1f. You can see that it printed out only 2 and not 25. This was the variable types in Python. There are other ways that we can convert strings. For example, age is equal to 25. If we printed out age, it should print out with us 25. So we can make another variable, call it age underscore conv, standing for converted. And we can have here age into a string. And then we can add age. And if we have here age underscore conv, we will also get 25. However, this 25 is a string and not an integer. It's quite tricky. However, you get used to it and you get to understand what a string is and what an integer is by time. You cannot add to a string, but you can add to an integer. For example, if you have print out here, and you can have age plus 1. And then you can add the same for the age, for the converted age to string plus 1. And you will see that the first will bring out an error. You see, you cannot add to a string, but you can add to an integer. If we commented this out, by the way, you can do that by using control backslash. And now if we run again, see now it's 26 because age is addable, but strings are not. And the same goes for booleans. Now let's delete this and start from the beginning. Let's understand something about strings that is called sequences. For example, if I've made my name equals to a string called ma1, what if I only wanted to print the first letter of the string? We can go to the print function and we can say name and then open bracket, straight bracket, and we can have 0. 0 here is the start of the iteration because we start our iteration from 0. So this is letter 0, and this is letter 1, this is letter 2, letter 3, 4, and so on. So we should expect to get the first letter in the string, which is M. If we clear here and then we run the code, we get M. So if we want to get the final letter, well, we can count 0, 1, 2, 3, 4, 5, and then 6. So if we have here 6, we should automatically get N. However, if a string is too long and we don't have time to count each letter, what should we do? That's simple. We can simply add here -1. And now we would get the same thing, N. So now we know that we can go through iterations through strings, no matter how long they are. If I added everything, it will give me the J, because I have the -1. If I have -2, it will give me D, -3, and so on. So the iteration from the left side starts from 0, and from the right side starts from -1. Now let's learn something about Booleans. We can do something that is, for example, is raining. And we can say false. And now is sunny, we can add that to true. Now we have two Booleans. We can use those for logical operations. For example, if we use the print function, and we have is it rainy, or raining in general, a question. Is it raining? And now we can add the Boolean value of is raining. After a comma. And now print is it sunny, and now comma is sunny. We forgot the parentheses, which is very important. You can add this all entirely. Yeah. So now if we run the code, you can see that this is false and this is true. So we can also do something. In addition to this, we can use variables inside variables. For example, is good weather. So in a good weather, it should be sunny and not raining. So we can simply assign this to is underscore sunny and not is raining. So we can use this in a print function, and we can say the weather is good, and we can have this as is good weather. And we can add another one, is bad weather. In a bad weather, it rains and it's not sunny. So we can say is raining and not is sunny. And we can also say print the weather is bad, question mark, and now we can have is is bad weather. We're printing out the is bad weather value and the is good weather value, in which each value is going to be connected to both variables is sunny and not. And not is also embedded within the Python library, so you can use this as default. There are defaults such as the true and false. Python already understands what those mean, so you don't have to think about it, you don't have to come up with it. And now if we run the code, yeah. Is the weather good? True. Is the weather bad? False. Why? Because it's not raining and it's sunny. If we switch the values, they will be also switched. So if I said here true, and here false, they should automatically switch. There's also another logical operator called OR, which we can actually introduce now. So, if it is a good weather, it should be sunny, or it should be raining. The weather can be good in both cases. So instead of and not, we can have something that is called OR. And OR here will automatically choose which is true. So if it's sunny, it will become true, and if it's raining, it would also become true. So in this case, the good weather is good is going to be also becoming true. See, now it turns true. So no matter what values is the is sunny and what values are the is raining, it will always become true. And that concludes our Booleans and logical operators.
Membership operators. Membership operators are divided into two main sections. Membership, as in, not in, to check the presence within a list or a string, and identity, is not, to compare between object identities. If we use the list of fruits, apple, banana, and cherry, if we print out apple in fruits, the output should be true because apple is indeed in the list of fruits. If we say orange not in fruits, that is also true because it is not in the list of fruits. Now we have two lists, X and Y. Be very, very focused on this part because it's very confusing and it can be really easy to misunderstand. Now we have two different lists, X and Y, both of which have different objects in the memory. So what Python does is store the X in a specific object in memory and Y in a specific object in memory. So when we say X is Y, this checks that the identity of X and Y are literally the same object. However, when we say X double equal Y,
which is the comparison operator, that means that
if X is actually equal to Y, carrying the same values in the same order as each other. That's why when we say X is Y, it gives us a false output. And when we say X is double equal Y, we get true. And now we go for the alias assignment, which is Z equal to X. And now this changes the case because now we've assigned Z with a new reference to the same list of objects that X refers to. So basically, we've just duplicated it with the exact same object. So now, if we want to make sure that the objects in X are exactly the same as the object in Y, we will get that the output is true because they are the same objects. Now, someone would say something advanced as a question, how can we check if both objects or both lists are the same? That's easy. Let's check that ourselves. So, if we want to check the ID of each of these lists, we simply write print, and then we open bracket ID, and then X. And then we go down, and we make another print function, ID Y. And then we print ID Z. And now after we've assigned X to Z, we should see that both IDs are matching. So let's run the code. Now you can see that the ID of X is similar to the ID of Z, and that is because we've assigned both of them together. And now you know what the membership operators are, such as in, not in, is, and not is, and why they can differ based on their memory location within the computer. So now we're going to go into something called bitwise operators. Deep down on the computer level, there is something called bitwise operation. The bitwise operation is mainly used for low-level computation. Such low-level is stored in integer as sequences of bits, zeros and ones. Bitwise operators let you manipulate those bits directly. It's very useful for performance and very critical for coding. Low-level protocols, graphics, cryptography, and more clever coding tricks. So now we can see here that we have X and Y. The binary representation of X10 is 0, 0, 0, 0, 1, 0, 1, 0. This is if we are taking into consideration an 8-bit. If it's only 4 bits, it's going to be only 1, 0, 1, 0. By convention, coders use 0b to represent binary operations, 0o to use octal operations or base 8, 0x for hexadecimal or base 16. If you don't know about those, there shall be another video away from this course that really describes what the meaning of those three. However, for now, I'm going to show you how to easily recognize all bits when it comes to zeros and ones in base 2 or binary. You can see here that we are representing this number with 0b because it's binary. 0b101, which is the 4 bits 101. So basically, it starts with the nearest possible, eliminating all the zeros and starting with the nearest one. For example, it takes away all the zeros, so it becomes 101. Someone can ask me, how can I know the binary representation of 10? Well, of course, you don't have to memorize it. But let's see together, how can we know any number representation when it comes to binary? We can simply use the function bin, and then add the number 10. And then here, bin, and then add the number 6. And now let's run our code. Nothing's going to show. Now why is that? Because I have not used my print function. And now we can do the same here. And now you can see that the computer itself provides you with the binary representation of both. I want you also to notice that the convention of the computer always approximates to the nearest one. So it deletes all the zeros and then it starts printing from 1. As you can see here, it's 0p110. Not like we've typed here 0110. We wrote this because it's a 4-bit representation to make things easier. But the computer will always eliminate and will write down or print out from the nearest one. And now you know how to identify any number in bitwise operators. Also, you can use your calculator or the PC calculator or conversions from online websites.
Now let's jump into bitwise operators. Now we have A, B, and C. There's something called the bitwise operator AND. What AND does is basically the following. If there is a 0 and 1, it will always choose 0. If there is a 1 and 1, it will choose 1. If there's a 1 and 0, it's the same as 0 and 1, it will choose also 0. And that leads to the binary representation of 2. Because if you print this, it's going to print out 2. We shall see as well the same thing with the OR, but the OR decides to choose the 1 instead of the 0, unlike the AND. So if there's a 1 and a 0, or a 0 and a 1, the OR is always going to pick the 1, such as here. 0 and 1, 1, 1 and 1, 1, 1 and 0, 1. And that represents 7 in binary. You don't have to worry about what the binary representation of each number is. You just have to know how those bitwise operators work. Bitwise operator XOR. XOR is typically OR, but with an exclusion. For example, if there is a 1 and 0, it's going to be 1. If there's a 1 and 1, it's going to be 0. If there's a 0 and 0, it's also going to be 0. Exclusive OR makes sure that there always has to be 1 at either sides. Both can't be matching. And that leads to the binary representation of 5. Now for the bitwise operator NOT. The NOT operator exactly does the opposite of what the binary representation is. If it's 0, it turns it into a 1. If it's 1, it turns it into a 0. So here we have 0, 1, 0, 1. So the outcome should be 1, 0, 1, 0. And that is correct. And this is why we have 1, 0, 1, 0. Now, it's also important to know that when you are using the NOT operator, there is always a 2's complement infinite. So meaning it's 1, 1, 1, 1, 1, 1, and then there is a 1, 0, 1, 0. However, when it comes to the positive side, it's 0, 0, 0, 0, as we have seen up here. And now you can see that if we print M, it's going to print out -6. And now using the left shift operator, you can see here it's 2 less than signs. If we use X left shift 2, this is going to move the final 2 bits 2 places to the left, exactly how the direction of the less than signs go. So you can think of those as arrows. So now you have the binary representation of 3 as 1 and 1, and if you use the shift operator and then you place 2 here, so it's going to shift the place of the bits by 2 places, or 2 zeros. And now you can see, now it became 1, 1, 0, 0. And that's the binary representation of 12. And if you want to go for the mathematical way, you can know that 3 times 2 times 2 is 12. And now for the right shift operator. As you can see here, we have the decimal representation of 9, which equates to the binary representation of 1, 0, 0, 1. If we right shift those bits by 2, we're only left with 1, 0, because we're going to right shift those, and those are going to be deleted. So we're going to be left with 10. So now you know how right shift and left shift works. And now let's practice some variable swapping using XOR. For example, we have here variable A and B. A is equal to 5, B is equal to 9. And yes, you can equate them like this. So now we have A XOR equal B. So that means we're going to make the XOR operation between A and B, and we want the result. So in the first operation, we're going to assign the answer to A, the second operation to B, and the third operation to A. So now let's do A XOR equal B. So this is going to make the equation of XORing between
the bitwise number representation of A and bitwise number representation of B. And we can see here 1 and 1. As we can see here, 1 and 1 is equal to 0. 0 and 0 is equal also to 0 because the XOR eliminates the matching ones. And we have 0 and 1, which is 1 and 1, and 0 and 1 here is also 1. And then we use the value we've got in the second operation because we've placed A here. So now we're going to make the same operation, but with the answer we got from the first one. And now we can see 1 and 0 is 1, 0 and 0 is 0, 1 and 0 is 1, and then 1 and 1 is 0. This might be confusing at the start. However, when you come to know more about it, it becomes easier. As you can see, this brings us to the B value. So we practically switched the values between each other while we didn't know it. So now if we run the code all together, as you can see, the first operation is 2, the second operation is 7, third operation is 5, -6, 12, 2, and 9 and 5. So now we're done with this, and now we can know how bitwise operation works. Welcome back. Now we're going to talk about methods. What are methods? Now we have a simple variable called text, and now we've assigned hello world Python is awesome to it. We're going to learn how to use methods such as upper, lower, and .title. As you can see, all we can do is assign another variable by convention and then name it text.upper. Text is the first variable that we've named. .upper is supposed to uppercase the entire string for us. And if we print it out upper underscore text, now we're supposed to get all the text in uppercase letters. And now when we use the .lower to convert the string to lowercase, it does the same thing. We convert the entire string into lowercase. And now for the next, .title, which basically capitalizes each word in the string. And if we use .title, we should expect our output to be hello world Python is awesome, looking the exact same way. And now to learn another method called .split. As you can see here, that .upper, .lower, .title are all methods. They're originally all functions. We will know what functions are later on within the course. So now we have sentence variable. We've assigned apple, banana, cherry, date. And now if we assign the variable fruit list, and now if we use sentence.split and you placed inside this split a comma, it is going to split the string we have here on each time there is a comma. So now we should expect our output to be apple, comma, banana, comma, cherry, comma, date. And this is going to be our fruits list. You should know that split provides them in a list instead of a string. So basically, it converts everything it splits within a string. Let's see another example. Let's split using whitespace. So hello world from Python .split. And now we print out words is going to print out hello world from Python. Because we haven't specified anything into the split method, it's going to assume that we are deciding that the white space should be the indicator where we should split. Notice that this time I have just used the variable and straight away used the .split at the end. This is possible, but it's not recommended by professional convention.
It's always recommended by professional convention to make another variable with the splitted words inside, like we have here. Let's go for the .join method. We have a word list variable consisting of Python is fun. We want to join them together. So all we do is make a new variable and equate it to a string. And the string, we would just use the method .join and then use the variable word list. What this is going to do is going to combine the three iterations all together to print out Python is fun. What the compiled result of the variable sentence would be is Python is fun separated by whitespace. Now we're going to join them with a custom separator. Now we have the CSV line. We're going to join the fruit list we have up here so that they can be separated all together using commas. So now we can assign the comma that we can make a string with a comma that we want to join the fruits list. What that's going to result in is apple, banana, cherry, and date all joined together by using a comma. So the comma here on the string is basically an identifier of what the join method should do about the list it's provided. Now you know how to use methods.
Now we're going to discuss data structures, starting with the most famous data type, string. We have been using strings since the beginning of the course. We have here variable x. We have assigned to it the string hello world. You should know that string here will only accept a string like this. And if we want to check if x here carries the value of string or have the type string, we can use another function called type. Type, you can input the variable name inside and then we will get the output class string or the type of class string. Why class? Because string here is something called a class or an object. Also, type here is also a class or an object, but it operates the same way as a function does. So this is coming easier now. We can use the same thing for integers. We have here a variable called x, and we have assigned an integer to it with a value of 20. If we want to know the type of x now, we can do the same thing over again. The same thing goes with floats. Floats are literally decimal numbers. So far, we know about strings, integers, and floats. Floats are decimal numbers, integers are just numbers, and strings are characters. So, what about complex numbers? Complex numbers have two sides, imaginary and real. And for us to use a complex number, let's have an example right here. We have y and z. We can use our complex class and have 5 and 2. And by the way, when I say class, it's the same thing as a function. I'm just getting you used to it, and you can see that a class here is highlighted in green. If you use a function like print, it says it's a function. But if you go over complex, you can see it's a class. So that's why I'm using the word class, but it behaves the same way. So now we have the class complex here, and we have inputted the arguments or the parameters 5 and 2. So 5 here is going to be the real number and 2 is going to be the imaginary, which if you write this down on a blank piece of paper is going to result in 5 plus 2j. Now someone can say, hey, why the letter j? Can it be any letter? No, it's only j. Python specifically requires the letter j for describing imaginary numbers. For example, we can have here the variable z, and we can have 6 minus 7j. And now Python is going to understand that the string 6 minus 7j translates into the complex 6 and 7. And it's going to take 6 as the real number and 7 as the imaginary number. And then we can make some complex calculations. More on that later. However, and then we can use it for complex calculations. That comes in handy if you're doing some really complex programming or mathematical algorithms. Now let's discuss lists. We have here the list X. We have used the class list so we can put the keys apple, banana, and cherry. We've used double parentheses to put the list inside the class list. So now we can print out the type of X and it's going to output for us class list. Now also one thing to add on lists, that lists would result in the outcome of apple, banana, cherry in straight brackets like this, because you need to understand how this looks like so we can go into the next bit, which is tuples or a tuple. What is a tuple? So what is the difference between a tuple and a list? A list is mutable. However, a tuple is immutable. What that means is it cannot be adjusted. So for example, if we wanted to change, for example, a tuple here that is called 1, 2, and 3, and if we wanted to change that, we can say, hey, the index 0, we want to change 1 to 10, it's going to result in an error. But if we wanted to make a list, for example, here, and you can see that the tuple is always in curly brackets. That's how Python knows that this is a tuple. However, it's a list if it's in straight brackets. So be very careful. The type of brackets that you use can greatly influence the behavior of your code. And we have here a list, and we've assigned it to L, and we have 1, 2, and 3 in it. And if we wanted to adjust the first index 0 here to 10, it works, and it becomes 10, 2, and 3. I hope you now understand this. I have tried as much as I can to make this as simple as possible for you as a beginner in the language. And this will come in very handy the more you practice Python. And now let's use ranges. Ranges are simple classes. So we can use X here, ranges 6. This will generate numbers from 0 to 5. I've also included how the list would look like if you use the list function on numbers. So for example, you have assigned numbers to range 6, it's going to generate for you from 0 to 5. And if you used the variable numbers here with the class list, you can generate a list of all the numbers you have had from 0 to 5. So this should be really handy now. You're getting acquainted with how ranges, classes, lists, and tuples work. Now let's discover dictionaries. We have also got acquainted with dictionaries, so let's see how it works. X, dict, name, John, age, 36. It's going to literally create a dictionary with the key name and have a value John, and the key age with the value 36. And it's going to assign it to the variable X. And if we want to know what the variable X type is, we do the same thing. Now let's discuss sets. X here is a set which has apple, banana, and cherry. Sets are similar to lists and tuples, however, with a few minor changes. Here, for example, we have a variable called fruit, which we have apple, banana, cherry, and apple. So we have 2 apples. And notice that we are using curly braces for a set. So now, if we print out fruits, it's going to output for us curly bracket, apple, banana, and cherry. Oh, but we had another apple. but this is what sets does. It removes duplicates. And it cannot be indexable. So for example, if you wanted to get out the first index, which is Apple, it's gonna result in an error. So there is no indexing in sets. However, you can add and remove elements. This comes in very handy if you are going to specifically use something that you don't want to have duplicates inside, and you don't need the indexing part. So let's talk about frozen sets. Frozen sets is exactly what it says. It's a set that is frozen, so you can't use the add or remove functions to it. Now let's discuss booleans. We have here a variable x that we have assigned to it 5 using the class pool. Now this will result in true. However, it will result in true for all non-zero values. So that means if you have here pool 0, it will result in false. If you have pool empty string, it will also result in false. So as long as the number is not 0 or empty, it's going to always output true. Now for bytes. Bytes here can create for you literal bytes. For example, if we have used bytes 5, it's going to create for us 5 bytes with zeros. And we can see here that Python always chooses that hexadecimal conversion is always at place. So we have bytes here with hexadecimal conversions. If we want to check the type, we always use the type. And if we have an example here, we can use data equal bytes 5, and if we print out data, it's going to print out exactly that. So we have something called byte arrays. Byte arrays is literally what it says. We create an array of bytes. So let's try to do something about it here. For example, if we have an array of bytes called mutable data, and we have assigned it to 5. So now we can just adjust the first byte value as much as we want. So we have the 0th value to 225. And now you can see that the first value of our array has turned into FF. FF is the short for 225 in the hexadecimal base. And now we can go for memory views data type, which is another data type that literally does what it says. It views memory. So for example, if we have here data, which is equal to bytes, and we have included 10, 20, 30, and 40, and 50. So that means we have created an array that has 1, 2, 3, 4, 5 bytes, and we have assigned 10 to the first byte, 20 to the second byte, 30 to the third byte, 40 to the fourth byte, and 50 to the fifth byte. And now if we want to view specific data inside the memory, we can literally use the following. We can assign the variable view to memory view data. So we can use the variable data inside of memory view. And if we want to print it, we literally say view. And view, as we know, we can use the array here. And view, as we know, we can use the value from 1 to 3. This means it's going to print out the index from 1 to the third index. If we used 1 only inside that index, it's going to print out for us the first or the 1th index inside the bytes array, which is going to be 20, because we start our index from 0. So this is 0, 1, 2, 3, 4. If we want to print specific indexes within our array, we literally use the double dots here. So we specify the first index and the last index so we can get what's in between them. For example, here we have the 1 and 3rd index. So let's go together. So this is 0 and this is 1. So it's going to get us this, and then it's going to get us the 3rd. So 0, 1, 2, 3. So it's not going to get us the third. It's going to get us the one before the third, which is 30. So it's going to print everything within those two, then the first and the third. So we can expect to get this. So we expect to get this output, which is x14, which is the equivalent of 20 in hexadecimal, or x1e, which is equivalent to 30 in decimal. And we can use the method toBytes, so it can convert the view to bytes. If we did not use toBytes, it will simply print out for us 20 and 30. But I'm just getting you acquainted with methods. If you want to know more methods, you can always find out more about those methods online. You can always use Google if you get lost to know methods that you still don't know about. I'll also provide you with links for libraries that you can always refer back to if you want to know more about these methods.
Now, if we run our code like here, we have an error. We need to remove one of the lists here because this will provide us with an error. Now, if we run the code after removing the error-made arguments, we get the same values we expected.
Welcome back. Now we're going to introduce something new, an input function. An input function is similar to the print function, however, it's used to collect information from the user. So now we can use it, for example, to assign it to variable x here and have a string enter your age. And then we can print x so we can prompt the user to provide an input. So if we run our program here by writing down Python 3 and then the name of our file followed by py, it's asking us for the age. We can just say 12, and then it prints out 12. There's an issue. If we run our program again, and instead of a number, we provided a letter, and then press enter, it's also going to execute. So there's an issue. We don't want it to take any characters. We want it only to take integers. We can do that by simply adding int before the input. And now, if we save and run our program again, and if we enter an A, it's going to cause an error. It's going to say, now there's an error. We cannot take an A. It's only working if it's an integer. Value error. So that explains the input function. Now let's jump into conditions. Now we're going to be introduced to conditionals. By conditionals, we mean if and else. And now we're back. We have here assigned a variable called age. We've done the same thing we've done as before with our variable x, and we have here enter your age to read the age from the user. And now we're going to use if, and then put our variable, and then the bigger than, and then equal. This means bigger than or equal to 18. If it's bigger than or equal to 18, then we're going to print out you're old enough to drive. Else, we're going to print out, sorry, you need to be 18 or older to drive. And else exactly works as it means. So if this is not true, this will execute. So now let's execute. And now let's enter 18. you're old enough to drive. If we execute again, I write down 17. Sorry, you're not old enough to drive. So this basically explains if and else conditionals. Let's have another example. Here we have a variable called score. We've assigned the score to 85. And now we made an if condition. We can use if conditions within if conditions. For example, if the score is bigger than or equal to 60, you have passed. But if that is true, then it will jump into the next if condition, which is if the score is bigger than or equal to 90, then you've done excellent. Else, you just have done a good job. If this was all false, and then it will print you have failed. So if conditions can come in handy, and you can see here that we had to use double if conditions to be able to go between the margin of 60 and 90. And this is very handy when it comes to programming. So now let's try to run this program. So now you know that if conditions can be looped within each other. And now let's run this program. You have passed, good job. So you can see that we have passed because it's bigger than 60, and that was true. So it went on and it continued to the next one. If I have done an excellent job, it would have said excellent, but I haven't, so it just printed good job. So let's see if we change this number to 55. And we run the program again. It's going to say, you have failed, which means that our program is doing great. So this concludes if and else conditions.
Now we're going to discuss using for and while loops. First of all, we need to know the difference between both. For loops, we use them only when we know the number of iterations. For example, lists, range, etc. However, using while loops, it's used while looping until a certain condition is met. And let's see that in practice. So now we have here a for loop. For number in range, range is also another function that basically provides the start and the end of something. For example, if we want to know the numbers between 1 and 10, we write down 1 and 11. Why 11, not 10? Because if this is our first index, that means that the computer will start from here. So that means that will be the number 0. Because the computer doesn't start from 1, it starts from 0. So if the computer starts from 0, it needs to take into consideration the number of iterations it's going to take. So for example, if you wanted to add from 1 to 10, that means you have to start your iteration from 1 and then to 11, because then you will have a sum between 1 and 10, and not the 11th iteration. So for that output, it's going to print us the numbers from 1 to 10. For a number in range, this could be anything. This can be X. This could be Y. This could be numbers. So let's see what the outcome would be. And now, as you can see, we have iterations from 1 to 10. If we made that so it's 10, the computer will only output until 9. Let's hit clear and run the code again. And you can see it only ran through 9. Because this means that the end of the iteration will be the number 10, so it will stop at adding the number 9. This is used by convention in all codes, so this will come in handy for you to understand. Now let's check another example out. Now we have a list. Let's clear the old operation. We have a list of fruits: apple, banana, mango, and strawberry. And now we can use for fruit in fruits. This could be anything. You don't have to confuse yourself. How does Python know what fruit is? It doesn't. You decide what a fruit is. A fruit can be X, or it can be fruit. Oh, I misspelled that. So now let's see what happens if we print the F string of I love fruit for fruit in fruits. That means it's going to go on each single iteration of the list and the strings within fruits and print I love next to the name of each of these single fruits. So let's test that. We run the code. I love apple. I love banana. I love mango. I love strawberry. So you can see that we've just iterated through the entire list. And that is another example of using for loops. Now let's go into a little bit advanced problem. Now let's assign a variable called total. And let's assign it to 0. 0 is going to be the sum of the total numbers. And now we can go make a for loop for num in the range of 1 to 101. That means it's going to go from 1 to 100. And then we're going to do total plus equal num. Plus equal is going to actually add the number each time it iterates to the total number. So, for example, if the first iteration is 1, then it's going to go for the second iteration and it's going to add it to number 1. So 2 plus 1, 3. And then it goes and does the same thing for all the numbers. And then we're going to print out the F string and say sum is equal to, and put here total. So we should expect to get the sum of 5050. So let's run the code and check that out. As you can see, the sum is 5050. Another problem here would be even numbers, knowing and identifying the even numbers and the odd numbers. For example, let's say we want to make a program that prints out even numbers from the range of 1 to 20. So let's see how could that be. We can use the modular operator and say for num in the range of 1 to 20, or 21 in this case, so we're writing down the iterations. If the number is divisible by 2, or mod 2, and equals to 0, so there's no reminder, there's no odd numbers there. If you want to know more about the modular operator, you need to know that every time you divide something by 2, there is a remainder. If there is no remainder, if it's equal to 0, that means it could print the number out. So this means it's going to print us all the even numbers from 1 to 20. So let's run the code and check that out. As you can see here, it's going 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. The code is running perfectly. That is just to give you an idea of how for loops are used in programming, so you get familiar and acquainted with how it works. So now we introduced the while loop. Now we've initialized the counter called 1. And this counter will help us to make the condition for our while loop. While loops needs a condition for it to actually work. It's very close to for loops. However, while loops always need something to be true. While loops can be broken out of easily using a function called break. But we will know that in a later on example. For now, let's see if we want to print out the numbers from 1 to 10 using our counter and initialize it to 1. And while the counter is less than or equal to 10, we're going to print out the counter. Some of you might think, why do we need that last line? Counter plus equal 1. This means that every time we go over the counter, we just increase 1 within the counter. This is the same thing as writing counter equals counter plus 1. So let's comment out this line to see out the result. If we run the program, it's going to keep infinitely print out 1. Why is that? Because we're not updating our original counter. So we can break out of this program by pressing Ctrl and C. And now if we return back the line that we commented out and run the program again, now it's going to print out from 1 to 10 because we have increased the counter every time the while loop goes. So the first time is going to increase it to 2. The second time is going to increase it to 3, all the way up to 10. Now some might say, why 10? And why did it not print out to 9? That is because we have the equal sign. If we have removed the equal sign, now only is going to iterate to the number 9, as you can see here. So it's very, very important that you know the signs you use for your while and for loop. And that is the first example. Let's check a new example. We have here an example of using the while loop to iterate through a list, exactly like we did with the for loop. So now we can have our fruits list, and we have an index we've assigned to 0. Our index is going to be less than the length of the fruits. Len is another function that lets you know how many objects are in the list. So now let's print the fruits with the index, which is going to change based on the length of our fruits. For example, what this function is going to do is if there is 1, 2, 3, 4, is going to have here 4. So every time we iterate is going to have to be less than and the number 4. So, and now we can just use the print function to print the index and increase the index by 1 every time. There is this number, we delete. And now we can just run our code and see what happens. And now you can see it has printed out apple, banana, mango, and strawberry. So this is how you index through a list using a while loop. Now let's have another example of using the break. Now let's have an example on using while loops for input validation. For example, if you want to assign a password from 1 to 5, or something that is critically between 1 to 5. So we use a while loop and we have while true. This is a Boolean. This means it's going to always keep going no matter what, unless there is a break. So the user input, we've assigned it to an integer, and we use the function input to enter the name. So the user input is equal to an integer, which provides an input which gets a number between 1 and 5, which asks the user. So basically the user is going to be asked to have a number entered between 1 and 5. And now we have an if condition. So using an if condition within a while loop is also possible. So if 1 is less than or equal the user input less than or equal 5, this means if it's between 1 and 5. If it's between 1 and 5, then we break. Otherwise, we print invalid try, try again. So let's try our code.
is going to ask us to enter a number between 1 and 5. Let's say I've entered the number 6. Oh, sorry, yeah, 6. Then hit enter. Invalid number, try again. And if I enter the number 6, it's going to also invalid try. If I put any number and press enter, it's going to keep giving me invalid tries. However, if I did number between 1 and 5, it's going to end the program. And now you know how a while loop can actually work using input validation. Finally, you can also use break within the for loop. For example, the list of fruits here, apple, banana, cherry, date. For fruit in fruits, print checking fruit. So it's going to check the number of fruits. So it's going to check between each and every of those iterations, and then if the fruit is equal to cherry, it's going to print out found the cherry. And then you can use the break to exit out of the if condition. So let's test that and put that to the test. Checking apple, checking banana, checking cherry, found the cherry. If we had placed the cherry in another iteration, let's say after the date, and now if we run the code again, it's going to check for apple, check for banana, check for date, and check for cherry, and then it's going to say found cherry. So this is how you use break within for loops. Now we've completed the for and while loops and using breaks within them. Let's jump to the next part.
So now we will get to identify something new that is similar to lists, that is called a dictionary. A dictionary is used the same way as a list is used. As you can see, a dictionary starts with a curly bracket instead of a straight one. A dictionary could have keys and values. There are also other uses for dictionaries. So, what does keys and values mean? So, for example, name here is a key, and the value of that name is a string called Bob. Age here is a key, and the value of that key is 30. Is student is a key, and the value of that is a Boolean false. This presentation can be also written like this. And you can see here we have a person, and here we have a person too. So these are different people with different values. So now we can understand how this works. But now let's try to access some of that dictionaries. And now let's try to access those dictionaries. So we can access them using the square brackets, like here. Print person, the name of the variable of the dictionary, and then have the name. The name is the key. So now we can output the value, which is Bob. Here, we can do the same thing. Print person dot get. Dot get gets you the value, if there is any. For example, we're getting the value height, but height is not a key value in person. So the output would just simply be none. Now let's check if a key actually exists. For example, if age in person, if the key age is in person, we will print out the value of that key. So that will be 30. But now let's try to update it instead of accessing it or checking if it exists. Simply, we can say person age 31. This will update the existing age of 30 and make it to 31. we have already printed out the age of the person in here. So it should be 30. And then after updating it, it should change to 31. So that will be very interesting to see. But let's check the last two lines here. Person2 name equals John. So now the new updated name, instead of John with a capital, it'll be John with a J small. And let's actually change that name entirely to make it something like Mark. So now the name is going to be completely different, and the output should be Mark if we try to get it. So let's run our code and check if our predictions are true. Okay, so the first output is Bob, the second output is none, the third output is 30, age equals 30. And now after we have updated, let's print out the new age. And now let's run our code again. Now it's 31. By the way, if you're wondering how my code is being auto-completed, this is because I'm using something called Copilot. Copilot is a premium service that Visual Studio Code offers. You can purchase Copilot directly from GitHub or try to access it from VS Code. You can literally hop on here and find what your Copilot can offer for you. There are some free prompts, so you can give it a try. One last thing, if we want to get the keys and values of any of those dictionaries all by themselves printed out, we should do the following. So now we have keys as a variable, and we have assigned person.keys, which is a method that gets you the exact keys of all those dictionaries. So it will get all the keys of person. And we have here a variable called values, which will get all the values using the method called values.values from the dictionary person. And now let's print keys and values. And let's see how it works. As you can see, it printed out the dict keys or the dictionary keys are name, age is student, and the dict values are Bob, 31, and false. So this can give you an idea of how to access dictionaries and how to use methods to access them and how to use square brackets to access them or other methods such as get to check if there is something inside that dictionary that is matching this name, or you can check if the actual key exists using an if conditional like here. There are many ways to access dictionaries. That just shows you how flexible programming is. You can always give it a try to access some of your own dictionaries to practice some programming.
What you've just learned is data manipulation. Data manipulation is a core fundamental in Python programming. So now, let's jump into the next bit. If you've reached this far, congratulations. You're almost at the end of the course. This means that you have already packed essential and fundamental basics of syntax, data manipulation, if conditionals, and more. And now, we will discuss one of the most important parts of Python programming, which is functions. Coming after will be object-oriented programming or classes. So enjoy this part.
What is a function? A function is literally something that can be called. If you remember, throughout the course, we've used a lot of functions and methods, like the print function. The print function is one of the functions that are used by default in Python. So now we're going to learn how to make a similar function but define it in our own way. For example, the function greet. For you to define a function, you need to start with def, which is basically the starting or declaring that the next sentence or the next word is going to be the name of the function. What's in those between brackets? After you have defined the name of the function, you need to either decide whether to give it a parameter or not. Sometimes functions don't need parameters, and sometimes functions do. But why do we need a function that has parameters? What is the variable name? That's easy. Name is not existent. You don't need to know what name is now, but you need to imagine that name will exist at the time that you use greet. For example, let's expand our function from here, because I have already written some code. So every time you want to expand or not expand your function, you can just click that arrow. So now we have the print function used here. Hello, f-string, hello, name. So now you kind of get an idea of what name can be. So name can be anything, literally. If we call our function by writing down the name of our function and opening a curly bracket with inputting a string Alice inside, the output should be hello Alice, because our function prints out hello and name. Let's test that. Hello Alice, hello Bob. So, is that the only use of functions? Of course not. Let's give it a few more examples. We have here two functions, add and calculate area. So in add, it takes two parameters. So wait, how many parameters can a function take? It's basically up to you to decide how many parameters can a function take. So in this case, we have two parameters. And here we have assigned a variable called result, and we have equated it to a plus b. So here we have assigned a variable called result to a plus b. So we can then return the result. The return function also returns the value. It outputs the value. So it sends the result back, just like the print function. However, it provides it for the user so he can use it. How can it return it? Let's see how. So now we have assigned a variable sum to the function we have placed in two parameters, 3 and 5. 3 plus 5 is 8. If we print out sum, it will output 8. Why? Because the result has returned the value of summing both a and b, which in this case is 3 and 5. It's confusing at the start. However, when you get handy with it, it becomes so easy. And now let's check out another function called calculate area. We have the length and width parameters. We will return the length times the width. And now outside of that function, we will print calculate area. So now we should get the calculation of those two numbers multiplied by each other, which is the length times the width in our case. Let's check the results of both functions. Now we have 8 and 20. There is many applications for functions. They are not just limited to multiplication, addition, or subtraction. They can be anything literally. Functions can involve for loops, while loops, conditionals, and more. Also, please take into consideration that if you call a function without placing its arguments, you'll always return an error. For example, if we use the function add and we have added nothing, it will not print anything. Actually, it will just get an error. So let's run the code. You can see that now we have an error. Why? because we have not placed any arguments. There are functions that are without arguments. For example, if we use this function greet, greet just prints out hello world. If we used greet, it will output hello world. So let's try this function, hello world. As you can see, there are many types of functions. Functions that have parameters and functions that don't. The functions that have parameters cannot be called except if their parameters are initialized. A final example on functions, we will here introduce a dictionary used within a function. So now we've learned what are parameters. We have a parameter here called name and age within the function createPerson. So createPerson here is going to literally do what it says. It's going to create an information about a person's name, age, and whether he's adult or not. And this is a dictionary, and we have here the key name, and we have assigned for that the parameter name, and the key age we've assigned for the parameter age, and is adult, we've assigned for it that age has to be bigger than or equal to 18. And then we should return person. We should return that dictionary. So now we assign P1 or person1 to create function, and we inputted the parameters Alice and 22. That will create a person that is named Alice, his age 22, and his age is true because he is bigger than or equal to 18. And the same thing we do here for Bob, and we assign the age 15 for him, so he should have this as false. So if we print out, we expect the output we've just said, name Alice, age 22 is adult true, name Bob, age 15 is adult false. Now if we want to access those fields within the function, all we have to do is print P1 name and print P1 is adult. It will provide us with whether the parameter is true or not, or what's inside the parameter if it's a string. Now we know we can use dictionaries and other things to create functions, such as if conditionals, for loops, while loops, and more. This is just an example to show you how flexible coding is and how functions are basically the fundamentals of programming. Classes in Python are serving as a blueprint for creating objects. It basically encapsulates data and attributes and behavior methods into single units. It's a very fundamental concept in object-oriented programming. So now let's understand what classes are. A class defines the structure and behavior of the object that it possesses. Objects are also known as instances. They are concrete realizations of a class. They hold specific values for the attributes defined in the class and can be executed as methods associated with it. So let's take this class for example. We have a class called logger. Logger has a function inside of it called log. Log takes the parameter self and message. Now the function log prints out log and message. So someone would ask me, why the self? That's a good question. Now on the first instance, you would see something called static method. Now what does that mean? That means it's always active. You don't have to worry about calling it. You just have to assign it to something and it will copy all of its attributes. For example, we have here the variable logger, and logger now was assigned to the class logger. Now logger will have all the attributes of the class logger. And if we use logger.log, which is a function within the class logger, we can use the exact same thing that the class has. For example, let's create another instance here and call it logger 2. And now we can literally just call our class. So now we have a second variable that has the same exact attributes within the class logger. And if we use it, we can also use logger2 and say system stopped, for example. Now let's print out and execute our code and see what's going on. You can see log system started, log system stopped. So that means we can copy the uses of the function instead of having to copy and paste it twice in a row for each of those variables. Instead of naming different variables or naming different functions, we can just simply create one class that can encapsulate it as an object referring to the function, and now we can use it all over our code. It is pretty rough at start, but once you get the hang of it, you will understand more. You always need to use static method, or else you can use self and then delete the static method. And now you're left with this. If you actually execute the code, it will still execute. It will execute the same because self here is the same as add static method. So if we run the code, we will get the same result. This is just to show you how classes actually work. There are more details about classes. It's a really deep subject, but this is a really broad explanation of how classes work. So you would know exactly what classes are and what their uses is. We have here a class called mathUtils. You can name the object whatever name you choose, but the name of the object is always good for you to identify what object is this class used for. In this example, it's called mathUtils. So we have here static method. A static method is good for capturing computation that is related to this containing class, but it doesn't need its attributes. So what does that mean? You just need to know that you need it so that your function can actually work and convert this function to static. Static means it's always on, always working. So if you call something within your class, it's always there. So now we have a function called add. Add has a parameter a and parameter b. And parameter a and b returns a plus b. So if we use the function add, we should get the output that adds up between a and b. So for example, here we have used mathUtils.add, and we have 3 and 5. So we should expect the output of 8. Now, what does this tell you about a class? Well, you need to know that, for example, if I wanted to assign mathUtils to another variable, we can do that too. For example, we can have here test1 equal mathUtils. And now, if we have here print function, we can use test1 dot, and you can see that now we have the ability to use the function add within test1. So what that did is copy all the attributes of the class mathUtils within test1. So now we can add here add, and we can have here 1 and 2. So let's run our code. You can see that we've printed out 3. This did not output anything because we have not used the print function. So let's use the print function right here. And close the bracket at the end. Now we were getting handy in programming. Now we should get 8 and 3. As you can see, classes here become very handful because we can assign them to another variables. We can do the same thing here for test2 and test3, and it goes on and on and on. No matter how many variables I can assign the class to, I will still get all its attributes. Or I can just use the class on its own with its attributes. There is another way to use our class without using static method here. What static method does is enable us to use the name of the class followed by its attributes. However, if we want just to use the class to assign it to other variables, we can just delete this static method right over here, and all we do is add a new parameter to the function we already have. So that will be self and now if we run our code, we should get an error because we're printing out mathutils.add, but we have not used our addStatic method. So we can just delete that or comment it out for now. And now if we run the code once more, we should get our 3. And if we wanted to do another one here, we can just add 3, 5. We could run the code again. It's going to print out for us 3 and 8. So now you kind of understand what is self. Self basically enables this function to be called without using the static method. So it's always ready to be used in other variables. So now let's jump into explaining all the things we talked about Python class. Now we'll take another example. We have here a class called dog. We've made a class variable because we've created it under the class and we called it canis. And now we have some function called init. What init does is basically call this function when the object is created. So it initializes the object's attributes using these. So every single object we create using dog is going to have a name and age, which is going to be essential. You can see here, for example, once we've created dog1, we have to assign it with a name and an age. Otherwise, the instance of a dog will not be created. And now we have another, which is self. We've also used self here. So now we have a function called park, and inside it is also self. So now this is a function on its own. And the function, all it does is just print woof. So we have dog1, and dog1's name's Buddy, and we've assigned it with the age 3. So dog1 here is our variable. And dog2 here is Lucy, and it has 5 years old. So we print out dog1.name. You can see now that .name here, when I highlight it, it also highlights self.name. Because any variable we will assign our class dog to, which is in this case dog1, will inherit all these attributes and instance variables. So now you know how self work. So if we want to use this function park, all we have to do is put the variable name dot park, and this will define itself as a method, and it should print out woof, like the example we have here. So now we used dog2.species. It doesn't matter if we use dog1.species, they both get the same output, which is canis. because this is a class variable and it doesn't change and it's not affected by our functions. So now let's run our code. And we get Buddy, Canis, and Wolf, which indicates how our code is working. So let's jump into another example. We have here class person. Person has an init, which is going to call itself, a self, which is basically our parameter that is going to be attributed for each of the variables we're going to assign our class to. So we have here self.name. So our variable should have a .name. This is going to be essential. Now we have here class method. Class method is simply another term for declaring self, but instead of using self, we just use CLS. So instead of self, we have CLS here. What the difference between self and CLS is that you can access and modify class level attributes, while static methods can't do that. Static methods are used primarily for utility functions that are related to the class, but don't need to access its state. However, when using CLS, you can do that too. So for example, we can return here CLS and we can open bracket because we can modify, not like self, and we can add here f string name, age, and return it. If you don't understand this from the first time, don't feel discouraged. It's okay. Everyone did not understand this the first time. You just need to know that CLS can modify on the first self attributes. However, self can't do the same thing. Just go over it a few times and read the syntax and you should be okay. And now for the usage of this class person. So we've assigned P here and person dot from birth year, and we've assigned Alice and 1990. And if we now print out p.name, we should get output Alice age, because this function is going to return the age but not the birth year. Pay attention to this point because it is a critical point. It should not return to us 1990, it should return to us the age subtracted from 2025. So if we print out p.name, it should print out for us Alice, age 33, because we have used the CLS to make a modification for our output. So our output now is not name, however, the output now is name and age, because this is going to be our new renewed output. Let's run our code. You can see that we have Alice, age 35. Another example of using the CLS, we have here class, my class, we have here account, we have assigned it to 0, we have self.value, we require a value, and my class.count plus 1. So what this means is every time we're going to assign we have here my class.count plus equal 1, which means every time we're going to assign a variable to my class here is going to increase the count by 1. What that means, if we have here instance 1, instance 2, what that does is just increase the count. We have here now count is 2 because we've just used 2 instances. So we have here a class method, getCount CLS and CLS.count. We're trying to get the count of how many times our class has been used. And now we have here class method, which creates instance CLS value, which is the value we've given at the start of our initiation of our class. And now we return the CLS value. So if we use the class method itself, we can use myClass.getCount. GetCount here should return to us cls.count, which is 0. So the output here is 0. And now we have an instance 1, myClass.createInstance, and we have here 10. CreateInstance is this function right here, and we have assigned to it 10. So now we have a value of 10 within our class. And now we have here instance 2, we have added here 20. 20 is another value. As you can see, the values here are different because, as you can see, we have increased the value one time using the .create instance. We added here 10 to the value, which is here, or we just add a value directly, 20, right here. So let's run this code. We have here 0 and 2. Why getCount now provides us with 2? Because we have assigned 2 instances. So the count has increased 2 times. If there was another function called getValue, let's create it right now. And now print instance1 dot get value. Let's have that into brackets here, and print instance2 dot get value. We should get here instance 1 as 10 and instance 2 at 20, because the second time we've increased the value of the class was directly using the init, so we have increased the value here. So this automatically increases the value of its own. However, the first time we have used the .createInstance method to increase the value that was in init. So now let's run the code and see what happens. Notice here I have an error. So as you can see here, the error says that my class has no attributes, and the error is at line 14. So if we check here that there's nothing wrong with our code. However, we have here add class method. So this is accessing the class methods, not our static methods. So if we simply just delete this line and run the code again, now our code is running perfectly, because this is accessing our static methods and this is accessing our class methods. So now you can get an idea of how to differentiate between class methods and static methods, and how important for you to understand the difference between both. It comes in very handy if you get to understand more about these methods, and it will be becoming more and more easier for you using practice and applying those in real-world applications.
So now let's learn about something called class basic inheritance. We have here a class, we've initialized it with name, and we have a function called speak, which takes self and returns 3 question marks, and returns 3 question marks. So now we have a second class, which is called dog, which takes in the class animal. So basically it inherits all the attributes from the class animals. And then it has another function called speak and returns wolf. if we now created an object using animal and we have just assigned it to unknown, and we have a buddy and we have a dog, and we have printed out generic animal.speak, which is the first one, and buddy.speak, we should get the output of buddy as woof and the output of animal here as 3 question marks. So what does that tell us? It tells us that we can inherit some variables within other classes. As we have seen here, this is called the parent class, and this is called the child class. And this gives you an idea of how class inheritance work. Now, if we run the code here, we can get the same output as we have. Now we will discuss multi-level inheritance. We have here a class called vehicle. Within it is wheels, and we have here a function called info, and it takes self and outputs a string has self wheels. So now we have another class called car, and we have inside car super dot init wheels. So what that line does is basically inherit the attribute wheels from class vehicle. So how does it know this? It's because it's inheriting it from vehicle. So the super here just literally takes wheels from the other class and adds it to this class. As you can see, once I highlight it, it highlights the other class as well. So as you can see here, it takes the other value of self. So now we have a second value that we've added. It's called brand. And inside here, we have also another function called drive, which returns vroom. And we have here another class called electric car, and we have a function in it called charge, and it returns charging battery. Now let's test those. This is called a grandparent class, a parent class, and a child class. So now we've created our instance. Let's call it Tesla. So Tesla, we've assigned it to the class electric car. And we have here for and Tesla. As you can see here, so now let's test this. We've assigned Tesla variable here to electric car. But electric car, if you go over it, it takes wheels and brand. But how? Electric car here has nothing. How did it have here wheels and brand? So what that means is it's inherited the brand and the wheels from the grandparent class. So now we have inherited those variables. Now we can use them. So if we use here for and Tesla in a string, because if we have 4 wheels and the brand Tesla, we can output here dot drive is going to output vroom from the class car, and dot charge is going to output charging battery from the class electric car, and dot info is going to output has number of wheels, has 4 wheels from vehicle, the vehicle method, the vehicle class, and print Tesla dot brand is going to print out the Tesla from car class right here. So now let's run the code and check
if this code is working correctly. You can see that our code inherits successfully from all the other classes and successfully uses the print function to output the outcome we desire. Now, this is an example of inheritance, and this is a very important aspect, and some might consider it really difficult at the start, but I promise you, as soon as you start practicing it and getting yourself acquainted with how the code works, you will become very familiar with the syntax, and it will not become complicated for you whatsoever. You just need to know that when you're using super.init and you have here a parameter, it just copies the parameter from the class you have added here as a parameter. So this just concludes the inheritance from subclasses and grandparent classes. Welcome back. Now let's discuss file I/O. We have here something called text modes. Text modes are literally what it says. So we have here text mode. In the world of programming, for you to actually access a file, you need text modes. Text modes provide the program with what are you exactly intending to do with your file. For example, R here indicates that you are reading your file, which is the default. And W here is write, which is going to be also overwriting. A is append or adding at the end of the file, and we will get to know how that works in a bit. X creates a file if there is no file and fails if the file exists. T is used exclusively for text mode, explicitly. What that means is it's only used for text files. So now we get to know what adding a plus to those text modes allows you to do. It simply allows you to read and write instead of only read. For example, if there is a read, whereas R, if you added a plus next to it, is going to allow it to read and write existing files. For example, if we use only the mood read and we added a plus to it, it will also allow it to write. If we added a plus next to the mood write, it will also allow it to read. So, and finally, if we added the plus next to something like A, it will also allow it to read, but it would not allow it to write because append is only adding to the end. So these are some of the examples of using add. And now there are also other binary modes, such as RB, WB, and AB, which appends or reads or write in binary format, which comes in handy in memory manipulation. So there are also some compilation of modes together. So if we added RT or XT, this will allow it to only create text files, for example, and fail if it exists. If it's an RT, it will read a text file only. If it's a WT, it will write a text file only. And if it's an AT, it would append to a text file only. This comes in very handy in something called log files, which is very, very handy in programming. So R plus T here will have read, write permissions because of the R plus, and then T will be only for text files. And then XP is going to be exclusive binary creation. So here we have the X, so it's going to create the file if there is no file and fail if it exists, and it will be only for binary. I hope that gives you an idea of text modes and how they work, because they are essential in understanding how file input and output works. So let's jump into the first example. We have here a common file mode demonstration. We have a file path variable, and we just equated it to the string demo.txt. That means we've just named our file name to demo with the format .txt. So now let's know how can we open this file. Now we're going to introduce something new called with. With is literally what it says. It's with something. So with the function or with the method, you can use as, and then you can assign another variable name for it. So this is going to transform itself into a variable. And now every time we want to call this or mention this, we just need to use this new variable right here. So let's get more into it. With open, open is a function that is with the standard Python library. With open file path, which takes file path and the permission name or the mode name, which is going to be write. So we're going to write to this file and we're going to write to it the following. And by the way, if you want to know what does open here takes, you can know the following. As you can see here, the top of the function def open parentheses file mode and then buffering encoding errors new line close fd and opener. These are all parameters that you can use and manipulate of your file. For now, we're just using the file name, which is the first file description or path, and then mode, which is the file opening mode, such as string R or string W. So now we're opening it as file. And now for us to adjust on that file, all we need to do is use a method called write. So file.write, this is line 1, and then new line, and then file.write, this is line 2, and then new line. And after we have completed this, the system should print out for us write mode complete, file created with 2 lines. Now, where would that file be created? I don't remember going into our file folder and creating anything called demo.txt. So we can go here and we can check our local file. We will find there is nothing so far. Now, if we run the code here, as you can see, it says here, write mode complete, file created with 2 lines. And if we now check our Explorer once more, we will find that there is a new file called demo.txt. So if we actually open demo.txt, you will see this is line 1 and this is line 2. Now let's jump into another example. Now we have here another example using the append mode. Now the same thing we did with the write mode, we will open our file using the file path, and then in 2 commas right here, we will have the A or the append mode. And then as file, and then file write, this is line 3, appended, and this is line 4, appended. What this means is just going to add it at the end. Now let's run the code here and let's know exactly what that means. And by the way, notice that our original file has now been overwritten with our new appending here. So it deleted our old file or modified on it. So it basically added to our original file the 2 new lines. And you can see this was appended, which means this was added at the end. You see, the write mode does not add at the end. It just adds based on your request. However, the append mode adds at the end in the specific order you want it to. Now let's check out another thing. Now if we want to go through the read mode, we need to also take into consideration some new methods. So with open file path R as file, and now we have a new variable called content. We've assigned content here, so it could contain file.read. What this means is that this opened file right here is going to be read, and then it's going to be assigned to this variable content. So now if we printed out content, we should be able to look into our demo.txt file without having to hover over the left side here and clicking on it ourselves. So now let's close this and run the code. And now you can see that after printing out read mode full content, we have this is line 1, this is line 2, appended, and appended. So this gives you an idea of what read mode is. Now let's discuss another mode. By the way, there is another Now let's check out another, Now let's check another mode. Now for the next one, now let's head for the next one. Now let's check out the next one. So we have here read specific characters. So if we wanted to read only specific characters, not the entire file, we can do so as well. We can name, instead of our content variable, we can just name it first 10. So, and then we can add here file.read, and then inside of this, we can just add how many characters are going to be printed out. So have here 10 characters. And by the way, if you wanted to know more about the file open and the file IO input and output standard library, you can find that on W3 Schools or the Python official website documentation. So now let's jump into it. And now let's run our code. So now let's run our code. Now it's jumping into the first few lines. Since we have already asked for the read mode here to give us what's inside the file, and here we have another read mode that gives us the first 10 characters, we can see this is the li is the first 10 characters. Take into consideration that it is calculating space as a character. So if you counted 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, these are complete 10 characters. If we want to read specific lines, all we have to do is the following. With open and then file path r as files, and then lines.readLines, which is another method within the documentation that we can use that reads specific lines. You don't need to worry about each of these methods. You just have to read the documentation and make sure that this method does exactly what you want it to do. Later on, you can even modify your own methods, but that does not hurt you to depend on the original referenced documented methods on the original Python libraries. So here we have read lines, which literally returns the list of lines from a stream, which means that it reads the lines instead of reading the words or reading the entire file. And now we can use a for loop for line in lines, which is this variable. We remember using the for loops. We're going to use them here. So for line in lines, we're going to print out an arrow that directs line.strip. So what that means, we're going to strip each of these lines from the space at the beginning and the space at the end. And it gives you can see here the description returns a copy of the string with leading and trailing white space removed. So now let's run this. You can see it has this. You can see the difference here between the full content and the line list length is 4, as we saw here, because we're using the len, which gives you the number of inputs or the number of the variables used inside of it. So we can now conclude that this right here is we can now conclude that this is reading lines as a list. And this means that we can read them the same way we read lists, if you remember going or looping through lists in Python. So now let's use one of the updated modes, which is R+, which allows us to read and write. So now we have the original, we have here file.read. Now it's going to read the file that we already have at the start, and it's going to seek 0. So this means it's just going to go at the beginning of the file, which is here, this point. So we are going to write start marker and then add a new line plus original. So that means we're modifying to what's already in the file right here. So we're adding to the original text, because as you remember, we have already added everything that we have right here. So for us to add plus the original right here, it's just going to add to the file. Let's run the code. And now the header has been added. Now if we check our file now, you can see that we have here start marker. Now if we want to just make sure that what we've done right here is also good right here in the terminal, we can just add a final result. So we can have here open file path, read only as file, and then print final content, and then dot read. And this should print us the final results after the R+ mode here added to header file string. So yeah, you can see start marker, this is line 1, line 2, appended, and they're all under final content. So this gives you an idea of what a file input and output is. But you need to necessarily know that when you open any file, you need to close it, because Python cannot read two different files at the same time. You have to close the file before opening the next one. And before we do that, let's clean up what we have done so far. Now we have our file path here, demo.txt. Now we can just go into F1 and then open, and then file path with write mode. And you can see as soon as I click the commas, it provides me with the options which I can pick from. And if you feel the need to understand any of those options, you can Google them and you will find plenty of guidance there. In this case, we just want to use the write mode. So now f1.write, and then we can just have here, this is line 1, and we can just print F1. And we can just have here the printed F1. So now you can see that the code was outputted successfully. If we go to our file here, you can see that this is line 1. So now we can just go and read the file. So F1 equals open, and let us just copy this. And instead of write here, we can just click read. So f1.read, and we can just have it equal first file. So the first file is the F1. So we're going to read the first file now. So now we can just print first file, and that should be printed out in the command prompt. This is line 1. So now let's write in file number 2. And we can just copy the same thing and then copy the same line here and have it file number 2 and have here number 2. And then we can just print F1, no, F2, and now we can just use the same thing we did here to read the file and call it F2, and then second file equals f2.read. And now we can just print out the second file. So what do we expect to get now? We should get a file containing this is line 1 and this is line 2. Well, let's check it out. Oh, wait a second. This is weird. It firstly made a file and had inside it this is line 1, and then it created the same file
and have it had this is line 2. So let's check out our original file. Oh, we have here only one line, which is the last line we've had, which is this is line 2. This is for the mistake that which I have told you about, which is not closing the file after opening it. So this makes the data that you will be writing compromised, or it might lead to its destruction, or basically its corruption. So let's try to add the close file here. So f1.close. And this makes sure that the data here is saved. And now let's do the same here after we have read it. Oh, sorry about that. Let's just take that here. And now we can just, let's put this close file at the end after the print function. Yeah, so our code is a little bit more organized. And now we can use the F2 close and F2 close here. So let's try again. It's the same problem. So I think the issue here is because two things. The first of which is that we need to add here a new line, and we have to add the next one in the next file, also a new line. The second issue is that we are not writing to the old content within the second file. We are just writing down in the original file and ignoring the content of the first. So what we should do here is F2 write, and then we should write to F1 or the first file. So now we're writing to the first file, and then we're writing again within this first file F2 hello file number 2. And now we should expect to get the outcome we desire. And you can see now important data hello file number 2. This makes sure that you are writing to the first file that we have created here. And this adds up to this creation and then lets you add exactly upon that. And now you get an idea of how exactly input and output work. This comes in very handy. It's quite challenging to understand at the start. However, I made sure to explain this to you in the simplest way possible, so you don't feel that it is challenging for you to understand. And I hope that I have done this very good so that you cannot feel that this is overwhelming and that it requires a lot of effort. I made sure to give in the effort so you can easily understand it. There are plenty of more examples online, and you can use all these online resources that you can find on Reddit, GitHub, or even communities online, so you can get more practice with opening files and closing them, or even other programs and other syntax.
Now we will discuss some other term in Python called error handling. Error handling in Python is primarily managed through use of try, except, else, and finally blocks. These blocks just allow you to anticipate potential errors and try your code, preventing the eruption of the program and its termination. So we have here an example, try, where we have here the variable num, where it presents a number, and we have an integer input of entering a number here, So we will ask the user to input a number, and then we will divide this number by 10, and then we will print out 10 divided by this number is this result. So now we have an exception here of a value error. A value error, so this basically means we will provide an error if result here is not a number. So let's try this out. Now we should run the code. It should ask us for a number. We can just say 20. 10 divided by 20 is 0.5. If we run the code once more, if we have, for example, here a letter A, and if we press enter, and it would say this is not a valid number. So there's another case, for example, what if we divided by 0? You can see that if we divide by 0, Python doesn't like it, because in Python you should not divide by 0. So let's make an exception for that. So we can say something like the following. So now we've added a new line here, except 0 division error. This is another class that can be added into the except. So we say here except value error, so except the wrong type of value. And here except 0 division error, this will allow the code, once it divides by 0, to print out the exception error, you can't divide by 0. So let's run the code again, and we divide by 0. Oops, here. And you can't divide by 0. What if there was another type of error that we don't know anything about? For that case, there is even another line we can add. So now we have an exception as E. E here can be any variable, but as convention, it's used is E, and we can just put E here. This will make sure that we can avoid falling into any unexpected errors that we don't know anything about. This comes in very handy in coding. So now we know that our code can expect any types of error. This involves syntax error and other hidden types of error that we can fall into. So now our code runs perfectly, and now since our code runs perfectly, and we can't divide by 0. Oops. We can't divide by 0, and we can't put a letter instead of a value. We have a good code, and our code is also compact with our exception as E. Now we have another example. This is not going to Now we have another example of using try with except, and with an addition to another thing called pass. So we have here a normal file being opened as F, and we're going to print out this file. So there is no file. We have not declared any variables with this file string right here. So we should not expect for this code to work. So if the file did not work, we should go into the except here block. So if the file did not work, we should expect ourselves to be going into the except block here. So if the file not found error, which is a type of error, by the way, you can find all these errors on the documentation of the Python website. So now we have decided that if this error happens, we can just pass. This means it will do nothing and it will return to us no errors. If we run this code, it will just print for us program continues, because we have not done anything about it. Now we have another example. We have a function here called divide and has the parameters a and b. If b here is equal to 0, it will raise an error. Raise is literally what it says. It raises an error that you cannot divide by 0, and then it returns A divide B. It will not continue if the error was raised. However, if this condition was not true, it will normally return A divides by B. Now let's test this. If, for example, we wanted to print divide, and then we have here 10 and 0. So we should expect to get custom cannot divide by 0. Okay, yeah, now we have an error. As you can see that we cannot divide by 0, and this is the error raised. As you can see here also, 0 division error, custom cannot divide by 0. So whatever you put here in the string will be outputted like in the violet area here, like as an error. And it will also say why it was an error. So now we have an idea for it. So let's try to use try and except to actually catch if this error was caught or not. So all we do is add here try, and we have here except, and now we have our code. So we just put it, the print inside the try, and except we had a 0 and we named it as E. So the division by 0 error, we're going to refer to it as E. And now we will print caught our own exception if this was to come true. So let's try this. As you can see, now it's not giving us the error line in divisible by 0 like it used to before, and now it's just providing us with one line, caught our own exception, custom cannot divide by 0. So now we know that we can raise our own errors, and we can name them customly, and we can modify them to output custom outputs. Now we will discuss the use of something new called finally, the finally block. The finally block is just going to run whether there is an error or not. Here we have a try block that has a variable f that opens up data with the read mode, and we have assigned data variable with f.read method, and we printed out the data. And we have an exception error here. If the file is not found, it will just print out file is not found or file not found. And now for the finally block. The finally block is going to always execute whether there is an error here or not. So what should we expect by that is for it to execute nevertheless. Within this finally block, we have another try block that closes the file we have just opened. And it's going to have an except name error. This name error, if the file is not there or f is not existent, all is it going to do is pass. So it's not going to cause another error. So that will help us make sure that the file is always closed if we opened it, and it will pass if we have not even created that file. So we can run the code now, and we should expect to get file not found. Notice we have not got the other error here because we have an exception for the error name error. And that concludes finally block in error handling. Welcome back. Now we will discuss libraries. Libraries are also an essential part of programming in Python. You will find libraries all over the web, and you can find even more libraries that are related specifically to the default libraries of Python over the Python or W3 Schools websites. So now let's import and use our first library. So let's see how a library is called. We can call our library by simply import and then adding something like math. This is a library. So now we have imported a library called math. And yes, it's just simply math. So how can we use this library? So we can say print and then math, and as soon as you click the dot, you will see methods. These are all methods are within math. So log, log10, log1, mod f, these are all methods. So now we can use pi, for example. Pi here is a number. So if we wanted to print pi, for example, we can just run the code and you can see 3.1459265, and it goes on. And notice that it has a limit because pi is infinite, but the computer can only handle this amount of digits before it stops. We can also print math dot square root, and we can have here, for example, 18. Now if we run the code again, we will find the square root of 18. And there are many more methods that can be found within math and can be used. So now you have an idea of how importing a library works. Now let's jump in to making our own library. So now we want to create our first library in Python. First of all, we need to know that there are some things called packages and modules. Libraries are modules. Packages are a short term for folders. So for Python to identify packages, it needs to know if this folder exists or not. And for you to have a module, it means for you to have a folder that ends up with .py. So right here, this, my first program, is a module. So let's rename that to main.py because this is going to be our main program. So now let's add another file and let's call it my library or mylib.py. So now we want to have some code in my library and then use it in main.py. So let's create a few functions that we want to integrate to our main.py. So now we've created three functions: greet, add, and square. So these three functions we now want to use in main.py. So all we have to do is the following. We can say from my lib or my library, because it's a module, import, and now we import the functions that we're going to use, like add, and we use the print function to add two numbers together. And make sure that we have saved our file here, and then we run our code. And we have 3. So now you can see that we can easily import and create our own library. However, it can go even further. So let's create a new package or a new folder here and call it my first package. And then we can transfer mylib.py inside of it. Okay. Now if we try to run the code again, we need to add my first package.mylib so we can run it. And if we run it again, then we can get it. But the difference is that now our main.py file is outside of the package of my first package here, which contains my library file. So what does that mean?
now we can extend on our main.py. So let's have here another file and call it init.py. What init.py do is execute immediately as soon as you call your library. So let us try that. So if we have here print library or lib imported. So now if we save this file and go to our main and run the code, you can see library imported. So this runs automatically as soon as you put it inside your folder. In addition to this, we can add even more libraries. For example, we can have here another file. We can call it my second lib.py. So my lib.py, my second lib.py. So now we can add another package. So now we can add another function here. For example, we can say subtract an A, B, and we can subtract A minus B, and then that's it. So now we want to use our exact functions that we've used in my library in our main one. So what that does is give us the ability to access everything inside of it, instead of us having to go from my first package dot second import the sub. So instead of having this line right here, we want to be able to access this very swiftly. Now, because this can be annoying when you add too many imports, we can have a solution using the init.py. So what we can do here is the following. We can say from my lib import add square and greet, and then from my second library import sub. So this means it's going to automatically import it for us when we call this package. So instead of calling the modules, we can just call the package, and we can say from my first package import add. But if we run the code now, we will get an error. And this is one of the most common errors in Python programming when it comes to creating libraries. Even advanced programmers do fall into this error. And I can't tell you how many times someone had fallen into this error, and specifically because of this problem. So now we can fix this by going into the init and looking into our importing here. You can see that we are importing based on our referral point based on our referral point. So this is going to be executing and looking at the referral point of main.py. What this means is going to look into the package of main.py, not the package of my first package. So that means its focal area, it's not this folder, rather it's this folder. So what we can do here is change that referral point by just adding a dot. And a dot here says that, hey, I am focused on the referral point that I am in right now. So what that means is going to relatively import those files, and then it's going to give it and refer it back to the main. So now we can use the same code after we save, And if we run the code right here, it's going to run and say library imported and the result at 3. I hope this was simple enough. I tried to make it as much as simple as possible. You can practice more on importing libraries and using libraries, but this is how you import and use libraries. You can also add and refer to libraries within each other. So for example, if you wanted to use some of these functions, for example, if you wanted to use this function in this module right here, you can add it in this module by simply referring to it and saying from dot my second lib import sub. And now you can use sub here and you can simply use it and it would work. Of course, this does nothing because we are not doing anything with the result of sub, and then you can know how exactly these types of things work. Now, a last thing about the init file, it's not supposed to be run. If you try to run the init file, you'll always meet an error because you're trying to relatively import a not known parent package. It does not know that it is inside this package and it feels itself outside of it. So the init file is not for running. Its intention is to be able to refer and to connect modules and connect packages with each other. So I hope that gives you an understanding of how packages and modules work. If you're unable to understand how these modules and packages still work, you can repeat the video and go over it slowly until you're able to grasp the concept of modules and packages.
Welcome back. Now we're going to discuss APIs. APIs is a short for Application Programming Interface. It's simply a set of rules and specifications that allow different software applications to communicate and exchange data with each other. Think of it as a middleman that basically lets two separate programs talk to each other, and it defines how they request and receive data and functionality. So now let's see how they work and how actually APIs come into practice. For example, here we have a website called PokeAI. PokeAI has 10 billion API calls each month, so it's a very good practice API so we can work with. What it gives you is information about Pokemon. So for example, if you give it a name like Ditto, Ditto, I'm not sure that's the right spelling or not. I'm not really familiar with Pokemon, but it's a good example for our case. And right here is the name of the Pokemon. Of course, this data can vary based on the name of the Pokemon itself if we changed it. So now we get to take a look on how the data looks like. As you can see, it looks here like it's a set of dictionaries which have keys and values. Of course, we have already reviewed keys and values, so we should be familiar with it. If we want to see how the JSON data looks like, it looks like this. And what JSON is practically a dictionary for dictionaries. And what JSON is an open standard file format which allows you to read the data in a form of dictionaries that consist of names, values, pairs, and arrays. So now we know how the data looks like. We have the API link over here. So now let's get back to our VS Code and copy this code first. And let's make the first procedure. So now before we start, we need to actually import the library that is responsible for AI manipulation. We can just import, let me delete the space right here. So we can import requests. And you can see we have here requests. Of course, when we import requests, notice that it's underlined by yellow that it's not accessed. That's because we don't have the module requests in our folder or package. So before we actually install requests module, we need a virtual environment. A virtual environment is simply a place where you download and put your modules that you will use for your code. Why do you need a virtual environment? Simply because you don't want these modules or folders get mixed up with your original or standard libraries. Because sometimes if modules get mixed together, they can create a lot of errors. So to avoid these errors, you need to create an environment for each project you make. So you know exactly which libraries you're using and which libraries you're not. For example, we're going to be only using this library right here. And this library is not from the standard libraries which we normally use. So let's create our environment. So we come here to the terminal and we write down Python -m venv. venv is a short term for virtual environment. And what that tells the interpreter that, hey, we want to create an environment. And then we press space and then we enter the name of our environment. So it will be venv, which is the name of our environment. And now we press enter. And you can see on the top left immediately we have created a new folder or a new environment. If you actually jump into that environment, you will see we have lib or libraries and scripts and include. If we go into lib, we will see something called pip. Pip is a module that is used to install packages from the web. And scripts here has data related to the virtual environment. For example, activate right here is what activates your environment. And before we install our package right here, we actually need to activate this environment. So for us to activate this environment, all we have to do is the following. Dot, and then /venv. That tells the interpreter, hey, we want to get inside this folder, and then another /scripts, and then another /activate. So, hey, we need you to get inside this folder, inside the scripts folder, and then use activate or run activate. That's what the dot means. So the dot here is to basically activate or run this file. So now we can just press enter, and now our virtual environment is activated, and you can see it in green. And by the way, if you are having some trouble with your virtual environment, please make sure that you find how the virtual environment is activated from Google. Because if you're using a Mac, these commands can be different. Now let's get back to it. For us to actually install requests, all we simply need to do is write down pip, which is pip, and install, and we can just enter requests and enter. And you can see here, you may have installed Python packages into your global environment, which can cause conflicts between package versions. But we don't need to worry about that. That's why we have already made our virtual environment. And you can see there are some files that are added now into our library, and we don't need to open our library anymore. We can just close it. And now it's also asking us to install an update for Python, which we can run by simply copying this command and pasting it over here and pressing enter. And you can see it's updating pip. Okay, so now we need to actually use our virtual environment. So you can come here and you can see that we have the version of Python, which is 3.13.3. But if we click it, you can actually see that we have an option of selecting interpreter. And now you see that this is the global interpreter and this is the recommended interpreter. And this is the recommended interpreter for this program because we have just created it. And by the way, you can also create a virtual environment from here. And you can just name it and it will be automatically created the same way we did it from the CMD or the command prompt. Now let's select our virtual environment. And now we are using our virtual environment. And you can see that automatically the yellow line is now removed and you can see everything is imported. So now let's jump into the next bit. Let's clear the command prompt and the following. So firstly, we need to initialize our URL. Let's make a variable, call it base underscore URL, and equate that base to the string, and inside that string we will put the link which is in the Firefox here, and we can just go back and paste it. So now we've assigned our URL or API to a variable. So now we're done actually making the base of our URL. What do we want our program to do here is get the information that we require it to get about the Pokemon that we give its name. So let's make a function that will get us the information about the Pokemon and everything that is about it. So now we can make a function we can call get. So now let's make a function called Pokemon info. So Pokemon info here will take the Pokemon name. So we need to put the name of the Pokemon inside this function, so we get the following. And we can just close that and start becoming inside the function. And now the URL is going to be changed based on the name it's given. So we need to make a new URL and make it equal to an f string of the base URL and then after that we just add a slash, and then after that we just add / and Pokemon and then / name. Name and then / the Pokemon name. So why this specific f string? Easy. So now if you see here, we have Pokemon and then the name of the Pokemon. So meaning if we actually come here, we will use our URL /Pokemon and then / the Pokemon name which we will require to get its info. So now we need to actually get this data. So we need to actually get this data from the URL, and that will require us to use our requests library. So now we need to get a response from the API or the URL so we can use it in our function and print out the information. But for us to get that response, we need to use the request library. And that's why you always need to know what's inside those libraries. Reading the documentation of libraries helps you become a better programmer. You will require to actually read some of those libraries so you can get acquainted with what each methods do. So now let's response. So now let's make a variable called response. And inside response, we can just make it requests dot get. We're basically getting a request. And then inside that request, we can just paste our URL. So let's actually make that a little bit adjustment here. So let's adjust that a little bit. And now we have a request that gets the Pokemon name from the URL. And we saved it in a variable called response. So now we want to know if actually the response we get was successful, or actually getting that response is successful. There is something called status codes. Status codes are an indication of how the URL behaves. You are familiar with the status code 404 or page not found. And now we actually get to be introduced to a new status code 200, which means the getting was, or the page loading is successful. Now let's make a condition for that. If the now let's make a condition for that. If response dot status dot status code equals 200, we do the following. And by the way, there's a website online that gets you all the information you need about status codes. You can see informational responses from 100 to 199, successful responses from 200 to 299, redirection, and more. You can see successful response 200, okay, it has succeeded, the API request was successful. And you can see here 404 is here, and that means that the server cannot find the request source or the URL is not recognized. So now you know how status codes work and why we need them. So after we get the data, we need to actually save that response in a format. However, if we don't save it in a format, it will be just mixed up. So now we need to actually save our data that we wanted to get in the JSON format. So now after we're sure that we got the successful response from the website, so now we have the response saved here in response. And we want to use this response to actually format the data into JSON. So now after we made sure that we have a successful access to the website, we need to make sure that we are saving our data in the correct format. So now let's save it in a JSON file by naming another variable. Let's name it Pokemon data, and then equal response, which is the response we get, dot JSON. JSON here is a method that brings out the data and formats it into JSON. It does that on its own. So now we should return Pokemon data. And else, if this was not true, we print an F string that says failed to get data from, just failed to get data, and then make an error code response.status code. So it will get us the error code and why it failed to get it. So basically we know why it failed to get the data. So now we want to actually use our function. Let's simply make a Pokemon name and let's call it Pikachu, the most famous Pokemon. So now we have a Pokemon name called Pikachu. So now let's make another variable called Pokemon status. And we can equate that to the function that we have used, which is Pokemon info. And inside that, which is our function, the main function here, and inside that we put in the Pokemon name here, as we actually made. So now we can just use our Pokemon name here to actually get the information about Pikachu. If we run the code, we should be able to get the information about it. So now let's run it. As you can see, nothing happened. That's because we're not printing out the information. So let's print Pokemon status and hit run again. You can see we have the data about our Pikachu, but the data is very, very complicated. We don't understand anything from it. There are some variables and keys here that we want, however, we don't know how to actually read it. So for us to actually change that problem, all we need to do is the following. So we make here another if condition, and we call it, and we say, so we make another if condition, and inside it we say if Pokemon status. So if we actually have Pokemon status working completely, we need to print Pokemon status, and then we can simply add name. So let's put that inside the if condition here. And now if we actually run the code, you can see we got the name, which is Pikachu, but we want more. For example, we want the age. So if you run the code, oops, sorry, there is no age. Maybe ID. Yep, it's 25. So the ID of Pikachu is 25. There's another example. If we want the height of Pikachu, it's just 4. I don't know the measurement units for this. However, it's just 4. But we want to use all of this. This is data manipulation. So we're actually manipulating the data to get the variables we want and the output we desire. So now let's make this more sophisticated. So instead of all of that, we can simply take that away and create an F string. And inside that F string, we can just say Pokemon status, and then use our data manipulation technique to get the name. And we can say here, name. And if we actually printed it out, sorry about that, it's all small case. It's called, yeah, now name is Pikachu. We can just copy this again and paste it multiple times. So, and now inside here we can just use ID, and here also ID, say here also height, and then here height and weight, and here also weight. Now if we run the code, we get these data. And now you know how to actually use APIs to get the data you desire. You can use even further data manipulation to get the format of your data in better shape. So, for example, if you use .capitalize, this is a method that capitalizes the first letter of the word. So now if you run the code again, you can see here, oh, I think we have used it wrong. Oh, yeah, we've placed it inside the bracket. So now let's use it outside the bracket here, saying .capitalize. And now if we save and run our code, Yep, now we have Pikachu, 25, 4, and 60, and Pikachu is with a capital letter. This was how APIs work, and let's jump into our next bit. Welcome back. Now let's discuss Flask. Flask is a lightweight, flexible microprogramming framework that is used by Python to build web applications. It's very famous among governments, famous companies like Samsung, Netflix, and more. It's very known for its simplicity and ease of use. It allows developers to create web apps quickly and effectively. Unlike larger frameworks, Flask does not require specific tools or libraries. It just needs its own library, and everything else is based on the coder or programmer. So now, let's actually understand how to use Flask. So for us to actually use Flask, we first need to install Flask. So we can use pip install Flask. And now it's going to install our Flask into our environment. Now, before you actually install this, make sure you are in a virtual environment so you don't use your global environment and mix up your modules. And as you know, we have already discussed how to create a virtual environment, and that's why we have used one in this example as well, because now we're going to create an app, and this is a project. So, after we have installed Flask, now all we need to do is import Flask. We can say from Flask import Flask, capital. And you can see we've imported Flask from the module Flask. And now we can actually start programming. So the first thing is, firstly, we need to initialize our app. So app equals Flask __ name attribute. So this means that, hey, this is going to be our folder which we will use Flask in. This one right here, the main.py. This is just an attribute which gives it the name of our app, which is app. So now we know that our app is initiated, and now we can actually use it. So now after our app is initiated, all we need to do is the following. So now, before we actually run the app, we need to give it a route. A route is like an address. For example, on google.com, you can see that there's a / at the end. Let's see that together. So here, for example, if we go to google.com, you can see google.com /. Now this / means that we are in our main homepage. So now if we go back, we can see that we can actually name our own route as well. So app.route, and inside there we can just add a /. This means like, hey, this / is going to be our home or our route. So now we can just run it by adding an @ before it. So we're calling this so it can actually be executed. Now let us write some code that can be executed within this page. So the function home, for example, will have return of hello, this is my Flask page. So now let us actually run the app itself by using the function app.run. So we go down here outside of the function and app.run. So we can see here that run here is a method that have a few options. And you can see that here we have a host, port, debug, and load underscore dot in and load underscore dot in. So we only need the first three. So what we're going to do here is the following. We need to put in a host. So we can say host equals, and then a string 0.0.0.0. What that means is going to run over all of our local host ports within this machine. And now we have a comma, and then afterwards we can just say debug and then equal to true. And we will know why debug here needs to be true later on. So we can now have another comma and say port, and we can just choose port 80, which that means that we're going to run our website on our local IP with port 80. So now let's run this code and see what happens. Now you can see that it is active. Our debugger is also active, and if we want to quit, we can just press Control and C. And you can see that these are our addresses that are running on our local machine. So let's copy one of them and paste it here. And you can see, hello, this is my Flask page. Now, let's go back to our VS Code, and if we wanted to adjust something in this code right here, between this and that, we can simply just add exclamation mark, and you can see down here, detected change in our main code, and now it's reloading. So if we go back to our web page, we can see that we have a exclamation mark. So this is a very effective way to actually debug your code. So now, as a courtesy of mine, I'll teach you something that you need to know as a professional programmer. So if you want to run this code in a professional way that can prevent you executing this file without actually running it yourself, because sometimes if you add more libraries or you add more files, things can get very, very difficult to run these thousands of codes. So this line of code right here will make sure that you're actually running this app itself without having to go through other files and running the other files that will lead to the run of this file. All we need to do is make an if condition, and inside that if condition we can do the following. If underscore underscore name, which is basically if we execute our code, or if we run the code right here. If we run the code and the code is actually the main inside a string here, this means that we will execute this. So this is just another way of saying if we execute or run our code, this will be happening. So now let's Control and C and run our code again. You can see now it's working perfectly. It's running the server main, the debug mode is off, and it keeps saying, warning, this is development. That's okay, you shouldn't mind this. And now you can see your addresses that are perfectly running fine. So now you know how to create your own web pages on Flask.